Hello students, welcome. I am your chemistry teacher Swathi Hegde. So what if I tell you you can solve any question from periodic table within 5 seconds if you learn these four tricks? Yes. So we are going to master periodic table trends in 10 minutes now. Let's start. First, let's start with atomic radius. The first thing we have is atomic radius. What happens to atomic radius along the period? Along the period. Along the period, atomic radius decreases. And why it decreases? What is the reason for decrease? Reason for decrease is nuclear charge increases. Increase in nuclear charge. Increase in nuclear charge. Because of that, electrons are pulled closer to the nucleus. So atomic radius decreases. Example we can take, see, sodium will be having higher atomic radius than magnesium. Then comes aluminium. Then comes silicon. Then comes phosphorus. Then comes sulfur. Then comes chlorine. So all this come in the same period. So along the period, what happens to atomic radius? Atomic radius decreases. And down the group, if I consider down the group, atomic radius will increase. We can see increase in atomic radius. Why atomic radius increases? That's because new shells are added. Electrons will enter into new shells, or you can say energy levels. New shells are added. When new shells are added like this, what happens to atomic radius? Atomic radius will automatically start increasing. So example for this one, lithium is having less atomic radius than sodium, which is having less atomic radius than potassium. Then comes rubidium. Then comes cesium. So this is how atomic radius vary along the period and down the group. Next, let us take ionization enthalpy. Next, second trend is ionization enthalpy. How ionization enthalpy varies along the period. First, let's consider along the period. What is ionization enthalpy? It is energy required to remove outermost loosely bound electron from isolated gaseous atom in its ground state. So along the period or across the period, ionization enthalpy increases. And down the group, if we come down the group, ionization enthalpy will decrease. Ionization enthalpy increases along the period and it decreases down the group. But we have exception. This is very important. Note down the exception. Usually questions will come from exceptions only. Beryllium's radius is greater, ionization enthalpy is greater than that of boron, and nitrogen's radius is greater than oxygen. So this is how the trend will follow. Okay, ionization enthalpy, usually it increases along the period down the group, but we have exceptions here. Beryllium is having higher ionization enthalpy than boron, and nitrogen will be having higher ionization enthalpy than oxygen. So next comes electron. Third trend is electron gain enthalpy. electron gain enthalpy. So how electron gain enthalpy varies along the period, across period. Across the period, generally it becomes more negative, and down the group it becomes less negative. So across the period it becomes more negative, and down the group it becomes less negative. And one more thing, we have exception here. If I consider chlorine, so chlorine has more electron gain enthalpy than fluorine. Actually, fluorine is supposed to have more electron gain enthalpy, but here chlorine will be having more negative electron gain enthalpy. Negative electron gain enthalpy. What is negative electron gain enthalpy? Energy will be released. That's why it's called negative electron gain enthalpy. When energy is released to the surrounding, we represent it with the help of negative sign. So chlorine will release more energy. That's because fluorine size is very small. Because of small size of fluorine, whenever we add electron repulsion takes place. That's why energy released will be less compared to chlorine. This is exceptional case. Next, fourth last trend is electronegativity. Electronegativity. So electronegativity is nothing but ability to attract electrons. So across the period, how it varies? Across the period, electronegativity increases, and if we come down the group, electronegativity decreases. So this is the trend. And which is the most electronegative element in the periodic table? Fluorine. Fluorine is most electronegative element in the periodic table. So these are few important things about different trends. And now let's solve few questions quickly. You have to start commenting the answers in comment section. Within a second you can answer these questions. Which one has highest radius? Take the first question. Which one has highest atomic radius? I'm giving two elements. One is sodium and another one is chlorine. Only 5 seconds. 1, 2, 3, 4, 5. Which is having highest atomic radius? Sodium. Sodium is correct option, because along the period atomic radius will decrease. Sodium will be having highest atomic radius. And the second question. Second question is, which has higher ionization enthalpy? Which has higher ionization enthalpy among nitrogen and oxygen? Whose ionization enthalpy is higher among nitrogen and oxygen? Nitrogen has higher ionization enthalpy than oxygen. Nitrogen is the correct option. Next, take the third question. Which has more electron gain enthalpy? which has more negative electron gain enthalpy. Negative electron gain enthalpy among fluorine and chlorine. Which is the correct option? Yes, it's chlorine. And the last question is most electronegative element in the periodic table. Which one? Fluorine. Fluorine is the most electronegative element in the periodic table. I hope you enjoyed this one and learned few tricks in periodic table. So for more updates, stay connected.